Now, since the power is back, I don't think I'll have as many issues. So go with grass again. I'll open my vector file. I'll put it on the edit mode. Or I think I'll not do that. I'll delete that one. For some reason, that probably got a little buggy. I'll go here, g dot remove. First, I'll clear the screen. G dot remove. Uh, I would like to know the kind of commands that I could give. So I could say g dot remove g dot list vector first, so that I know what my vector file name is. So that's region. I'm going to copy this name, press Q to exit the screen. G dot remove. I'll go back to type. I'm going to mention vector. Name is equal to paste, and I'm going to remove, but it's asking me to use the F flag if I permanently or force want to remove that, so any remnants are not left. So I'm going to do that this way. I'm going to go again. I'm going to open my RGB file here. Click OK. Open it in the window there. Create a new vector map. Give it a name, region 1. Create attribute table with it as well. I'll add it into the map window. I'm going to start editing it. So now it's in red and editable. I'm going to create a polygon for a certain area. My polygon is complete. I'm going to submit this one. I'm not going to do anything else. I'm going to quit the digitizer. I'm going to save my digitization. I'm not going to mess with it anymore. I don't want my windows to crash. So now I have a vector map. I am not turning off this thing, and I have my vector map as well. G.list vector, when I'm gonna control C G.list vector. So when I'm going to do that, I have a region underscore 1 vector map available with me. What I could do is I could go again and type the g.region command with the help menu, and I'm going to see the kind of options that I have. So I could actually use a vector to set my region. So what I'm going to do is g dot region dash um, p vector, and I'm going to say region underscore one as the file that would set my region. So when it did so, it reduced the number of pixels to 298,000. It set a smaller region for me. Now, if it has set a smaller region for me, this is what it's going to be like. So I'm going to open a display window. I'm going to go for my rasters here. I'm going to open probably one of the raster, and I'm going to see, and it's already reduced. It's actually a way smaller raster for all of them. But what it has done is it has not practically made the map smaller for me. What it has done is it has actually reduced the working region for me. So whatever now I do will not be reduced to a certain size or cut down to a side, but would be sized to my working region. So my previous working region was a different one. So if I look at this one, my previous working region was very different. And if I look at the working region that I've set now is a very small one. I could do it even smaller if at any point I would like to do it. What you're going to see peculiarly here is that you have an upper left, upper right limit, and it is grid like. It's like a rectangular shape that it has given it. It could have been a square shape as well. It is not something that you would get when you set up a working area mask. Now, what is a mask? When you're working with grass, you actually have this option of r.mask in grass GIS as well. What you do is you actually create a working region mask. So now when I'm going to do right now is now all of my files, whichever file that I had is actually set to the current working region. And I mean, I'm pretty easy now because I don't have to spend a lot of time in creating my working regions or maybe creating cropped rasters. All of my rasters in my workspace, in my location are shortened down, smaller, scaled down. I can print the current region again here. And if you see my current region limits are here and the number of pixels that I have are there as well. I can set it back to the previous region by just typing uh, the name of one of the files and it will set it up to the previous working regions. What I could do is g.lit raster, g.region, uh, p. I use the print command so that I get that on the screen as well. I'm going to say raster and I'm going to give it the raster file name, the original file name, and it has reset the region. So from 298,000 cells, I've come back to 6 million cells. When I would be working on 298,000 cells, I mean, obviously my work would process quickly. And sometimes you can have a Landsat image which has Lahore in it or maybe Islamabad in it, but you don't want to work on the entire area, which has like from Islamabad to Jhelum, every place. So what you would do is you would rather want to create a small working region for Islamabad, classify that only, and get on with the rest of the work. So that's one of the reasons that the grass g.region command is a very, very useful one. Another thing that you could do is you could create masks. So when you go for the r.mask command and type the help button here, you're going to see what you could do. Now, this is far more interesting actually when you're working on the raster mask command. So what I could do is I could actually either use a raster as a mask or a vector as a mask as well. Let me try with the vector that we just created. So I'm going to type r.mask vector and I could give the name region underscore one. That was the name of our vector file. And if I would like to use the category values, I could use one of them, but I don't know if they are, uh, what are they? Because where is the vector? What's going on? Okay. When I go back to the GUI, I'll pick up my vector file and look at the attribute table. I have a category value of 2 labeled as such on the vector. So I'll refer to that value, and because जो वो हमारा polygon का the area by the value 2. So for that matter, let me go back to that again. Open the vector file. See it here. This is the vector. Get the info. I have to select the vector file here. So it's giving me the area, the hectares, the acres, the square miles, and the category value that is stored automatically as the primary key, that is 2. The database driver is SQLite. So this is the value that is stored. So I would like to use this value as the mask value. So what I'm going to do is I'm going to say clear gr.mask help, and I'm going to type r.mask and I'm going to say vector. I'm going to say region underscore 1. And if I would like to use a certain value, that is 2, it created a mask. Let's see what it did. So now if I'm going to open a vector file or a raster file, let's say all of my raster file here, any of the raster file that I pick would be actually scaled down to this area, this particular region that I have selected. The good thing is now everything that I'm going to import or everything that I'm going to export is going to be actually masked to this region. And that's very interesting, because now I particularly know. So when you have a vector file, say for instance the political administrative boundary of a country or the political administrative boundary of a district, and if you use that as a mask, so rest of the area in your raster image will be covered out for you. Now when that area is covered, you are good to go. You actually do not really have to worry about cropping or masking and exporting or not. But if at any point you feel like you want to export the files, you can do that as well. So what I'll do is I'll go with the g.mask command as well, g.region command. I'm going to use the vector file that I have, region underscore 1, and reset the region as well, 298 times 7. Then I'm going to go to my data folder. Then I'm going to go to my Lancet folder. Once I'm there, all that I have to do is r dot now I need to export all of my files. So what I'll do is for I in g dot list raster type raster. Wait, just give me a second, please. G dot list raster, and I'm gonna look for no g dot help. So I'm gonna give the pattern, the name pattern. Okay. So what I'm gonna do is I'm gonna do for I in g dot list type is equal to raster pattern is equal to CLIP. So any file that starts with CLIP, so all the clip files, static, and I put that in inverted commas, you will see that this character here, this hyphen, that is actually the top leftmost key on my keyboard under the escape key. And this repeats here as well at this point. And then I say it in, and then I'm gonna do r.out.jadal input is equal to $I. So the I that is here is actually the variable that I'm saving the g.list type files in here. I'm going to say output is equal to $I dot diff, and I'm going to click done. No, something happened. do r dot, sorry. Oh, so the file already exists. Sorry for that. What I'm going to do is I'm going to probably add underscore one dot diff. Now I have all the underscore one name file exported. I'm going to open QGIS. If you see, I have I like the tips. They're very helpful. But right now, I think I would rather focus on what I'm supposed to do. I'm going to open the rasters that I just created. I'm going to click open and see the raster is already clipped for me. And there's no extra thing around it. So if you're doing it like in another software, like maybe ArcMap, you probably will have this very serious issue of using a very complex process to do so. Here, a certain set of lines of tools help me do that. So when you have like a vector map or a raster map, and the fact is that if I could create a mask using a category value, like when I was creating my mask, if you see, this was the category value that I used. The value is 2. So if I have like maybe a vector file for the entire country like Pakistan or India or Nepal or USA, and if I know that a particular county or district has a category value in the attribute table XYZ, I'll just put this value here. So I'll not even have to remove anything from that vector, just put the value for that particular district, for that particular UC administrative unit. It will create a mask accordingly for you. And the process is then very streamlined. So if you're working on a large data set, maybe on a heat island data set for entire Pakistan, and you want to quickly report on how it has been in Karachi or Islamabad, you are good to go. There's one more thing that I can do with it is when I need to remove the mask. So what I could do is I could say r.mask dash R. When I do say that my mask is removed. So when the mask is removed, I will actually be getting a different rendition of the same raster. There you go. So it's a bigger one. Now it's for the region as well. If I set it back to the original region, r dot region, clip 10, raster, clip 10, oh, there's no file as such, underscore 10, I guess. What was g dot list, raster, clip 10. Yes, it's the same thing. Oh, sorry, I have to write the whole thing. My mistake. G dot region, not R dot region. So it has reset that for me. This time it did not print it because I did not use the P flag. I'm back to my 6 million pixels. And now if I'm going to open the same, it is going to be different. I'll have to close this one, I guess. I have to close the GUI g.gui. I'm getting the entire area all together. That's good. At a given point, you might not want the kind of mask that we did. Now I'll go to the history of my commands, and I created the mask using r.mask. I'm going to go for r.mask, help again, and I'm going to see what else I can do. So I have an option which says, well, I've used the R flag already for removing the mask, but I also have this dash I flag, which actually is for helping me or allowing me to create an inverse mask. So when what I'm going to do is I'm going to go and create an inverse mask and see what it does. So I'm going to do for that r.mask dash I vector region underscore one cats 2. My mask has been created. Let's see what it has done. I'm gonna, oh, now this is an inverse mask. So the area that was under the polygon has been removed and everything. So it's a coconut, it's a donut it created for me inside a raster. This is something that's pretty difficult to do in other utilities. And as a matter of fact, you'll have to look around. I mean, obviously, if you didn't know graphs, you would have to still look around. But here it is done. And you created a donut. And if you would like to not, include a certain area in your analysis, that is masked out. So now if you're creating an RGB, if you're creating a classification, if you are exporting a data set, you will have this particular area masked out. So you'll actually getting rasters with donuts in between. So let's try to do that. I'm going to remove the uh, clip underscore static.tif files, the 10, and I'm going to export the files again. So I'm going to go back to the commands that I printed for exporting files, and I'm going to export the same files again. I don't have my QGIS open. I'm going to go to my QGIS again. I think I did something wrong. It didn't export. Yes, I have to actually use a no data value as 999, maybe 0. Mhm. Now this is going to be a bit, so it did not export any of the files here because I couldn't specify r dot out dot jadal. So it's asking me to specify a no data value. And the problem is that every value from 0 to 255 is already present in all of my rasters. So either I'll have to change the raster type to float 32. And if I do so, then I can specify a certain value, or I could probably do something else. I have been able to export it. There you go. So the donut is in there, and the value that I did not want, the area that I did not want, is not exported in it. And that's probably one thing that, I mean, you pretty much understand is very useful when you're working with a larger data set or a big set of images, and you would like to either specify a smaller area for your classification needs, or you would either like to export or crop a certain set of rasters. Uh, for me, this has been a very working approach. I mean, one of the reasons for it being a very working approach is the fact that I end up having to process big data sets, and this works a bit in a messy way, but still, of the view that my entire grass and my rasters and everything are the way that I want. So when I remove the mask, I'll obviously not have the same kind of uh, I'll remove the extra file that I created as well. So we're going clip underscore static.tiff, and those files are removed as well. So I'm back to the files that mhm, clip static. So I'm back to the files that I had originally before we started this exercise in my directory. Of some of the other things that Grass offers is that you can actually create a no data value, a null data, or do a variety of other operations with this mask function all together. You can actually even have a certain calculation included based on your attribute tables and create a mask with respect to that. So there can be an instance where you have census data. There can be an instance where you have maybe population age group data, or maybe you would like to say that any person or any district maybe of a polygon which has in its attribute table a population of more than 5,000 women only should be used as a mask. So once that is done, then you do the other analysis. So you would like to then see what kind of agriculture production happens there. And you will probably find out that maybe since there's very little female contribution or women contribution, there are some issues with how good the economy work there. And as a matter of fact, you can also maybe find out that you know other things accordingly. So you can actually use this function to do some preemptive calculation. And that is a very, very useful thing. So once your data is being processed, you don't have to really, sort of go post classification or post processing classification. Most of the things are pre-managed for you. And once you are like writing code, you could actually then include these steps in your processing pipeline all together. In addition to that, if you look at the g.region command, this is again a good thing. I did mention that you can set the computational region small. There can be instances where you have five or different particular regions that you want to process. So when you're writing codes, you can, for every set of process, use region 1, then use region 2, then use region 3, then use region 4, and then do the calculation separately on all of your regions. That is one way where you can actually optimize how your computer's memory functions. So this is again some examples that they have on their manual. And if you would like to go and pick, you could do that. These are some external commands. So actually it is pretty much possible to run commands on Grass externally as well. And then you have obviously other general utilities in Grass that you could use to do these kind of things. I would rather invite you to actually explore these and see how well they function for you. Since I would not be uh, obviously able to work each and every one of these commands in our exercises online. There's this very one interesting command that is known as the g.proj command. Let's see what it does. G.proj help. And it is actually printing something which has to do with the georeferencing of the vectors or the rasters that we have. So what I would do is I would rather for that matter like to see what projection I am working in. And if I do so, it prints the projection information for me on the screen. If I would like to actually print it in a different way, I could do that as well. Here, there are these options I can pick from. So if I would like to maybe go with the flag G, it would be in the shell style. If I would like to maybe go with approach for format, mm, dash J. And this approach for format is the one that is going to be useful for you to know, because when we are converting projections on rasters outside grass, sometimes, we actually all the time use the proj for notion. So when like there's this utility called Jidal warp, and it helps us do that. So I can get out of my grass, I could go to my Lancet folder, and I could type Jidal warp, and sorry, it's not Gradal, Jidal warp, and it's going to give me a set of options. And when we are giving in these options to this Jadal utility, it is the one that uses these proj for notion. So when, I mean, if I could print that in grass and I know what a proj for notion is, I could use that to reproject some of my data. So the data that I have here is the clip 20 for that matter. Let's say I'm going to create a copy of the clip 20 file. So I have now two clip 20 files. This is the copy that I have. I'm gonna go and type the projection for this one by using the Jidal info command. And it's going to give me the upper left corner, the lower left corner, and everything else of this file all together. The next thing that I could do is I could actually change this projection type. So if I would like to do that, I would use a utility known as Jidal warp, and I am going to use the TSRS tag. The TRSRS tag is the one that is used for T underscore SRS. Okay. Thanks to Stack Exchange. What you could do is you could actually go and you could use a TRSRS or any of these commands for uh, translating or changing it into a different projection system. I could also use another thing, translate, and it does a similar thing for me. These uh, these projection systems, when we do so, so what we do is, say for that matter, I'll go for Jidal Warp again, and it's actually giving me the TRS, so the target SRS that I would like to set. So what I could do is SRS, and what we do is we set the approach plus, and then I could say lat long or long lat datum is equal to, but I'll use the plus command before it, WGS 84, and then I could maybe go for the file names. So the file name that I have is the clip 20 underscore 1.tiff, and I could use clip 20 underscore 1.tiff reprojected. And it is, there you go. So what it did was it created another file for me, the reprojected file. I'll go for the Jidal info, type the name, and it's going to give me the projection that I created. It's going to tell me that it is obviously not in the same projection system that it previously was. And if you see, it actually is not giving the same values. Now it's giving me the latitudes and longitudes because I converted it into latitude and longitude projection systems. So that's the kind of things that, when you're experimenting things in grass environment and when you're going out and, are going to be pretty useful. So what I could do now is I could actually convert bulk projections for all of these files all together. So I'll not have to do it with, so what I'll do is I'll use my same loop for I in static.diff and voila, and do, and then I could create the loop and, reproject all the files. I would not do that right now since we have already been through 1.5 hours. I'm sorry for the power interruptions that I have had, but I mean, I'm sure all of you have that as well. And that did put my system under a bit of stress because it was too hot inside the room and, for some reason it was not working right. So if you have anything to ask or talk about, you could do so before I conclude today's session. Okay, so if you do not have anything to say or ask, first things first, obviously, I'll be very thankful for you guys to have joined in. I have to allow mic for everyone. I think for some reason the mics were locked. I'm sorry for that. I'm sure you guys could hear me.
Yes, sir.
Okay. तो I'm sorry वो power वाले issues की वजह से I'll conclude it now. Next time probably the timing I'll probably keep it at 4 to 5. So or maybe some other time where I'm not expecting or where I'm expecting that there would not be a power outage, so my computer does not get sluggish and I don't have a buggy session. Thank you so much. I'll be uploading the recording as well. Uh, and I'll share also with you a schedule for the internships that we are offering. And I will also be sharing with you the date and time for your drone making workshop during this month. So you can do it remotely if you feel like doing that. Thank you so much, everyone, and hope to see you again as well. Thank you. Allah Hafiz.
Thank you, sir. Allah Hafiz.
Allah Hafiz. Thank you, guys. Yes.